Okay, so I'm going to come back to the unit circle. So the unit circle, it's a circle with a radius of 1. All circles are symmetrical. This is going to become very important. It's symmetrical to both the y and the x-axes. Okay, so from the first video, hopefully the degree measures made sense. Start at 0, rotate 30 degrees, then 45, then 60. So the degree measures can make sense, and all the measures, I should say, are always measured from the x-axis. So this is where we start, and I'm going to rotate in a counterclockwise direction, and then I can get to any angle that I want on the unit circle. Okay, let me erase that terrible circle there. Okay, so I kept saying I'm going to come back to how you can determine what the radian measures are. So for our first quadrant angles, hopefully you did this. It's a simple, 30 degrees. To convert that, pi over 180, and then this would reduce to pi over 6 radians. 45 degrees reduces to pi over 4 radians. 60 degrees reduces to pi over 3 radians. And then 90 degrees is pi over 2 radians. 180 degrees is pi. 0 degrees is 0 radians. 360 degrees is 2 pi. And then 270 is 3 pi over 2. Okay, so you could go through this conversion of taking every degree measure, multiplying it by pi over 180, and reducing it. I'm going to use the symmetry. So I'm symmetric to both the x and the y axis. And the symmetry means I'm always going to refer back to one of my 3 angle measures in the first quadrant. So this first angle measure, the one closest to the x-axis, has to have a reference angle of pi over 6. So my 50-degree angle is going to refer back to my pi over 6 angle from the first quadrant. So 130 degrees is going to refer back to my pi over 4 angle, and my 120 degrees is going to refer back to my pi over 3 angle. But it can't equal pi over 6, pi over 4, or pi over 3. They're too small. So now let's look at what this does. So pi over 2 is 1/2 pi. Pi is 1 pi. So all my coefficients to pi in the second quadrant have to be fractions between 1/2 and 1. So you'll hear me refer to this often. So to get my numerator, my top number in the second quadrant is always going to be my bottom number minus 1. These angle measures have to be smaller than 1 pi, but they have to be bigger than 1/2 pi. So check this out. So pi over 3, my top number is my bottom number minus 1. So 120 degrees is 2 pi over 3 radians. My top number is my bottom number minus 1. So 135 degrees is 3 pi over 4 radians. 150 degrees, my top number is my bottom number minus 1, would be 5 pi over 6 radians. Now, if you did this after the 7-1 video, through the converting by pi over 180, then hopefully you got these correct answers if you did that simplifying correctly. All right, now let's move into the third quadrant. Using reference again. So pi over 6, I always refer back to the x-axis. So then this same amount of rotation has to be preserved in the third quadrant. So my first angle will refer back to pi over 6. 225 degrees would refer back to pi over 4. 240 degrees would refer back to pi over 3. Okay, so now when I look at my third quadrant, my coefficients to pi have to be between 1 and 1.5. Okay, they have to be between 1 and 1.5. So my relationship, my top number is going to be my bottom number plus 1. Because I need this coefficient to be a little bit bigger than pi. That's why I'm going to add to the denominator. So 210 degrees would be equal to 7 pi over 6 radians. Where did that come from? Because my top number is my bottom number plus 1. 225 degrees would be 5 pi over 4 radians. 240 degrees would be 4 pi over 3 radians. And again, I hope that you did do this after the 7-1 video, the first one I posted, and you're checking your work and it's correct. I promise you, with practice, radians will be they're much easier to work with. Okay, and then lastly, in my fourth quadrant, so I'm going to use my symmetry either to my y-axis or my x-axis, but I'm going to stick with the x. So same rotation from the x-axis. So 330 degrees will refer to my pi over 6 angle. 315 will refer to pi over 4. And 300 degrees will refer to pi over 3. Okay, now what's the relationship between my bottom number and my top number? So now in the fourth quadrant, my coefficient to pi has to be between 1.5 and 2. So remember, I always work from the x-axis. So my top number is twice my bottom number, and then I'm going to take 1 from it. Because think, if I doubled 6, that would give me 12 pi over 6. 12 pi over 6 will reduce to 2 pi. Well, I still need my angle measure to be smaller than 2 pi, but bigger than 1.5 pi. So pi over 6, I'm going to double 6, I get 12. I take 1 away from it. So 330 degrees is 11 pi over 6. 315 degrees, 8 minus 1 would be 7 pi over 4, and 300 degrees would be 5 pi over 3. This circle, my friends, will haunt you for the next 2 chapters. And if you make it recognizable, if you practice with it, then it won't haunt you. It'll be a lot easier. But I will be using radian measures as much as possible, because the higher math that you get, radians are what used. Degrees are not going to be used anymore. Oh, I don't want the eraser. Highlighter. If you remember pi over 2, 1 pi, 3 pi over 2, and 2 pi, then these relationships mathematically are going to make sense in your head. Okay, more videos to follow. For right now, all finished.